Why is the Bloch sphere vital for understanding quantum circuits? Imagine trying to understand a new language without hearing it spoken aloud. The Bloch sphere acts like a visual voice for quantum states, making complex ideas easier to grasp. When working with quantum circuits, especially those built with basic quantum gates, it helps to see what's happening to qubit in a simple, visual way. A qubit, the basic unit of quantum information, can exist in a superposition, meaning it can be both 0 and 1 at the same time. Instead of just thinking about these states as abstract numbers, the Bloch sphere shows us exactly how they change when we apply different operations. It's like having a map that shows all possible states a qubit can be in, represented as points on a sphere. The north pole of the sphere is the classical state 0, and the south pole is 1. Any point in between is a superposition, which is a blend of both. This makes it easier to understand how quantum gates, like the Pauli X gate, flip the state from 0 to 1. These gates are like rotations on the sphere, turning the state from one point to another. For example, a rotation around the x-axis flips the state from the north pole to the south pole. Other gates, like phase shifts, are rotations around different axes, changing the relative phase between states. This visual approach helps us see how quantum information is manipulated, which is much clearer than just looking at algebraic formulas. The phase of a qubit, which is key to quantum interference, is represented by the azimuthal angle on the sphere. This phase affects how qubits combine and interfere in quantum algorithms. Seeing this visually helps us understand why quantum algorithms can perform tasks that classical computers cannot. When designing quantum circuits, the Bloch sphere is a handy tool for visualizing how each gate affects the qubit. It makes debugging easier because you can see if a gate is doing what you expect. Many quantum software tools include Bloch sphere visualizers, so you can watch your qubit state change in real time. In short, the Bloch sphere turns complicated math into a simple picture, making it easier to learn, teach, and build quantum circuits. It bridges the gap between theory and practice, helping us see how quantum information is stored, changed, and measured at the level of a single qubit.